Hello, welcome everyone to an MTR Fab video. This is MTR. Today we're going to do something different. We're going to build a quadrotor, an FPV quadrotor. And all the pieces you see here are what's required to build something like this. So this is a Rotorx RX 122 V3. And this is a full FPV drone. It's approximately the size of my hand. It's sub 250 grams, meaning the FAA doesn't care that you fly it. This is the real deal. Does everything a professional race drone, FPV drone will do. So today I'm going to take you with me as I build another one. This is the last time I'm going to build one of these. I've built many of them. Unfortunately, it seems like Rotorx is no longer building this small 3-inch chassis, and that's what I like, so that's what I'm going to do. Take you with me as I go. So throughout the build we're going to use this one as our reference. The stack in here, these are all custom parts. This is not something that you buy as a kit. I purchased all these parts individually based on what I like and what I've built in the past, and this is kind of just the way it's ended up. It is hard to fit everything under these canopies because TBS, Team Black Sheep, that made these originally, did a very good job at engineering the stack that fit in here. My stack is all custom parts, and on top of this stack right here, let's see if I can point this stuff out. So you have your camera, you have your flight controller board, which is on top. This is so that's your receiver, and this is your, or no, I'm sorry, this is your receiver, and this is your video transmitter. I'm going to try to call out the pieces as I go, but the first thing you're going to need is a chassis or a frame. This is an RX 122 like I discussed. This is a Rotorx chassis. This is how it comes. I'm going to open up this bag off camera, but the first thing you need to do is file the frame. And this is not necessary for everyone, but I will tell you carbon fiber is conductive, and it is very sharp, and it doesn't like getting whacked on an edge. And so to reduce the damage when you crash, pretty much all pilots have found if they file the edges so they're not sharp corners, that the frames will last longer. So I do recommend filing the edges. You're going to want a set of gloves because carbon fiber is nasty. You're not going to want to breathe it, so try to keep it on the wet side and just file all the edges with a microfile. Here's the new frame kit all opened up. You get a canopy, you get the frame, you get a strap, you get some hardware and some wires, and you get a TPU camera mount. So that's kind of cool. The original camera mounts were not TPU, they were 3D printed, or not 3D printed, but injection molded plastic of varying angles. So I'm kind of interested. I may try this, I may not, but we're going to focus on this, and this is the guy that I'm talking about, that you need to clean up all these edges. And again, you don't have to, but they are very sharp, and I will tell you, when you crash you will appreciate it. It will do a lot less damage. Alright, it took me about 20 to 25 minutes realistically, probably more time than I'd like, but you can see, well, hopefully you can see that the corners have all been kind of just knocked off. And that's all the way around, even in these holes, because I feed antenna wires through here. So, I've deburred essentially everything. And this is nice to touch. You're not going to cut yourself on it, and when you crash, your first few layers will likely stay together. If you don't do this, they'll delaminate. Okay, we're ready to build. Okay, these are the motors we're going to use. These again are larger than I've ever used before on this particular frame. These are 1408, and I believe that's 14 millimeters of diameter for the stator and 8 millimeters high for the stator, and they're 3600 kV, meaning they'll spin at 3600 RPMs per a volt. And we're going to run these at 16.8 4S. 16.8 volts times 3600 will give you full tapped out RPM of this motor. Now we've got 4 of them here. We're just going to open them all up, and I'm going to show you what you get in the bag. You get a motor, and you get a hardware kit, which is just a prop nut and a couple screws to mount the motor. I think these screws are going to be too short. So usually you buy 2 different types of motors, clockwise and counterclockwise. They were not offered in this solution, so these are all, I assume, clockwise motors. I don't actually know because they weren't marked. But either way, on smaller quads, it's not so bad to have motors that spin all the same direction. That way when you purchase replacements, you don't have to worry about which ones you get. On larger quads, I don't like it because if you stall out a prop for any split second of time, the nut will actually fly off, and so will your prop. So these guys, it's not such a big issue, and I can run them all in one direction, and that's what we're going to do. So I'm going to mount these to the arms using some aftermarket screws that are a little bit longer than the ones that came with them. Alright, there it is with the motors mounted. You can see some 3D printed skids. These protect the ends of the arms and the motors. I've used these on pretty much all my builds. They do require you use longer screws, and it's actually why normally I wouldn't do these while I'm building it up, but if you can see in there, you cannot send too long of a screw in or you'll hit the coils on the stator of the motor. So the screws I have were too long without the crash protection, and the screws that came with the motors were too short without the crash protection. So either way, I ended up having to use the crash protection with the longer screws to make sure I wasn't hitting any coils. Now I'm going to set the standoffs on here, and then I'm going to show you how I'm going to squeeze the ESCs in there. And the ESCs are the electronic speed controllers. They're what dictates how fast each motor spins. A few of these little kits, standoff plastic kits, this is the kind of stuff you have to have if you're going to build these things, is lots of options. So I had to just go through, use the reference drone that I've built, measure the standoff, and now I've got 4 of those, and that's these lower standoffs. And then I'm going to use some of the Phillips screws right here, the Phillips plastic screws, to go into those standoffs. So I'm going to put those on this frame. You can see I have 2 different screw lengths. I have a long one and I have a short one. I'm actually going to use the longer one. It does thread all the way up into this body, but that's to ensure I get the best bond I can. I don't recommend metal ones here. TBS uses brass standoffs, I believe. I just don't, because I'd rather them break than not. We got 4 Littlebee ESCs. These are 20 amp ESCs. You know, probably 5 years ago when I got into this hobby, these were a pretty big deal, and a lot of people liked them. A lot of other people have since moved on. I still use them because they work. And the 20 amp is more than enough for these small motors, and actually the actual current on these new motors are unknown, but I've never had issues with the old units, so I think these will be fine, and it should be more than enough. Get them all out. Alright, we're going to show you these 20 amp ESC. So you have your power wires coming in from your power distribution. You have your signal wires coming in from your flight controller, and then these go out to the motors. Now you can see I have more than enough wire between the 2 of these, so we're going to have to substantially cut some off, one or the other. So I'm going to take the stickers off of these, and I'm actually not going to desolder any of this. If you can see on this chassis, the wires on the motors were just cut short, and the actual junctions for the wires were done right here. And there's a reason for that. It's very hard to get the heat shrink back over all of these connections once everything's tucked in. So it's easier to just leave them the way they are, cut this, and then do these connections out here. So I do want to talk about the fact that this is the complex way to do this, especially nowadays. Nowadays they have one board that does the function of all four of these. It'll be called a 4-in-1 ESC, or you can find 2-in-1 stacks. Now I do it this way because if one of these fails, I can just pick on it, pull it out, and replace it. Now you cannot do that with a 4-in-1 ESC. So the extra work I'm going to put in to get this stuff in makes the system ultra reliable and ultra repairable. Is it easy? No. All that gets stacked in here, and as you can see, it ends up being pretty tight. With that in mind, you have to do this nice and clean and be patient about the way you lay this out. And essentially, the stack doesn't even, I just hot glue these together, and they will sit stacked up on each other inside this lower section, floating below everything else. Everything else will be mounted to the standoffs, but the ESCs just kind of stay in there and float. Talk about the layout. The layout is probably one of the most challenging parts about building this, because everything's got to lay in the right spot. So I'm just going to point out a few things. This is how I'm going to stack the ESCs. You can see I have a set of motor wires going to the back for that wire, or for that motor, and I have motor wires going to the front. So the ESCs aren't stacked the same. They're stacked opposites. And then something else to consider is, where are the wires going to go? And this is the power distribution board, and you guys can't see it, but the power is in the right pad. So I'm going to make sure my top one has the power on the right side. There's just a lot of little things to think about in the way you lay this out, and I just wanted to share it with you because you have to wire these. So this corner is PWM number 1, and PWM number 1 is right here. It's these three first pads. PWM number 2 is actually under it, and it's right here. So all of the white and black wires are going to actually go to these 6 headers, or 6 solder pads on this side, on top, and on bottom. So a couple things changed since the last time I had this camera on. As you can see, all the ESCs are now in black heat shrink. Well, while I was manipulating them to get them moved into place, one of these wires just fell right off. So that gave me no faith in the soldering in the rest of it, so I actually resoldered almost all of the connections. So with that, instead of having solder joints here, I went directly to the ESC pads and just removed all of the wires and retinned and resoldered the pads. So now you can see what I've got. It's a nice clean little package where all the wires line up with this new Matek PDB here, and I wanted to show you the package because it's got a part number, but these are the ones I use in the micro builds that I do. There are other ones, but this one does everything I need it to. So as you can see, that's going to sit right in here now, and I'm actually going to hot glue that in place. This is a flush mount board on the back. There are no components, and then I can solder the respective wires. But what I want you to notice is the layout of the power wires. If you notice, the black wire is the negative, positive is the red, negative, negative, red, right? So I've got these all laid out so they go straight to where they need to go and they're not crossed over. It's going to save me as much space and weight on wire as I can, and it'll be the most direct path possible. Keeping everything tight is key to minimizing the weight and the cluster that you're creating. After I'm done with this, you can pretty much take this whole thing out as one piece. The flight controller is just going to sit over the top of that, and then we'll do the same thing with the other one, or same thing like you saw on the other one. Put the radio transmitter and the and/or receiver and the video transmitter on top. So this is just going to sit here like this in this orientation. See, these 4 little pads in the center here are for 12 volt and 5 volt. And I can't remember what I'm going to use those for. I think the 5 volt I'm going to use them for the camera, and the 12 volt I believe I use for the VTX. But either way, I have to tin all these pads, and I'm not going to do that inside the frame here. I'm going to do that out. So before I put this in, I've got to solder up pads and get them ready. Here it is, all tinned up. Now I'm going to start to cut these wires to length, one at a time. It really doesn't matter where your power wires go to the power distribution board. They don't have to be 1, 2, 3, 4 like they have to at the controller. The power wires can just go wherever they're convenient. The 2 inputs for the battery terminals are labeled BAT, and they're in the center here. And we're going to put an XT30, which would be a 30 amp micro connector on the end of that. Getting there. I can tell you the challenges with these power distribution boards is there's a lot of surface area to heat up because all the pads are connected together. So whether you're soldering grounds or hot wires, it's equally as hard because you basically have to heat the whole thing up to get the solder to wet out. You can see I got the back ones on, and this is what I'm talking about. The wires just come straight up from the ESC and go right into the PDB. Now these are the signal wires, and these are going to get applied to the flight controller. And after I get these other set of red and black wires up top down, then we'll move on. So there's all the power wires distributed from the PDB to the ESCs. So now I'm going to tack the camera wires on, and the flight controller power wires, and the receiver wires, and power in from the XT30. So looked at the KISS literature. This guy will take, I think it says 2 to 4S input, and it might even be more than that, but at least it's 4S, so that means I can run it directly off battery voltage. So you can see I made this little pigtail. There's your XT30, it's your 30 amp connector, and that's going to get stabbed right onto those 2 pads in the center there. And then I'm going to be able to break my power out up top. So that'll go into those pads, and then these 2 wires will go to the V in and V out, or well, it's V in here. Alright, this is as far as we've gotten. I think I'm going to have to call it a day here, because I've got all the basically all the flight controller and the power distribution wiring done. The only thing left is to put the video stuff and the radio equipment on it. But as you go, I can show you what I've got here. And this has taken quite a while to get here, but you can see how everything is stacked in there. Right, so there's your 2 bottom ESCs, your 2 top ESCs, and then the PDB. And then this flight controller sits on top. And I'm actually going to show you when you key it up what happens. So if I plug power in, so there's a lot of good things going on there. The tones sounded good, which means all the ESCs are online and synced. And there's a power light on the PDB below. Everything's working so far. With that, this is going to be a 2-part video. This is part 1. Thanks for watching. If you like what you saw, please comment and subscribe. I'm going to try to finish this up this week, and next week we'll have a video of it completed for you. This is kind of a time-consuming task. It's probably taken me about 8 hours to get to this point. With that, guys, I'll see you next week. Thanks for watching. I'm out.